Let's work through a couple of questions together where we're only interested in specific atoms or groups of atoms in a molecule. So for this part, we're just looking at one molecule of a particular compound, and we're zoning in on one element or one little group of elements, or pardon me, a group of atoms. So here we've got the question: how many hydrogen atoms in one molecule of ammonium phosphate? So NH4, 3PO4. So since we're only interested in hydrogen atoms, we're just looking for H's in this formula. We're only looking at hydrogen. I've only got one place where I see the H, and that's in the ammonium polyatomic ion here. So H is right here. And let's look at what's going on here in this formula. We've got a subscript 4 after the H. So that subscript 4 tells me that there are 4 hydrogens in one NH4 ion, or one ammonium ion. I've also got this 3 outside of the brackets, and that 3 applies to everything inside the brackets. So the 3 tells me that there are 3 nitrogen atoms, and there are 3 times 4 hydrogen atoms inside this compound. Okay, so because we're only looking at hydrogen, let's go ahead and do this. So the hydrogen atoms so we've got the 4 attached to the H inside the brackets, but then because we have that 3 on the outside of the brackets, I'm going to multiply that 3 by all of the subscripts inside the brackets. Okay, and again, if I was interested in nitrogen, I would be able to report that there would be 3 times 1 nitrogen atoms, but I'm not interested in nitrogen, I'm only interested in hydrogen. So I'm going to say 3 times 4 hydrogen atoms. So that's a total of 12 hydrogen atoms in this compound. And that's my answer. Now again, I'm only looking at one molecule of this compound. If I had more than one molecule, which we'll deal with in the next little section of the lesson, then I could multiply my answer for one molecule by the coefficient in front. So however many molecules I had, I could just simply multiply by that number. Okay, let's carry on. Let's do another example. Here we've got how many water molecules in one molecule of the hydrate beryllium nitrate tetrahydrate. Okay, so this time we're only interested in water molecules. All of these questions where we're looking at the number of atoms in a molecule, we just want to be careful, and we want to take our time to make sure that we're looking at the right element or we're reading the question correctly. Okay, so in this case here, because I'm looking at water molecules, in this formula, I'm only interested in how many H2O or water molecules are in this hydrate, in this compound. Okay, the whole compound is called a hydrate because a hydrate is any salt that has water molecules attached to it. And if you could visualize this, you would have beryllium nitrate in the center of the compound, and you'd have 4 water molecules that were attached to it. Okay, and so again here we're looking for water only. And so there are no brackets around the water, but there is this coefficient of 4 in front, and that 4 tells me that there are 4 water molecules, and it's just that simple. Okay, so there are 4 molecules of water in one molecule of the whole hydrate.